Hey Science 9, here's your lesson on the periodic table. We're going to go over the anatomy of the periodic table, where things are, and also talk about properties of stuff on the periodic table. Now, before you get going with this lesson, I would actually watch the crash course video on the periodic table, which gives you the history and talks about Dmitry Mendeleev's process in building the periodic table. It is absolutely fantastic, very interesting. So before you start, I would actually do that, come back here, and then go through the lesson. So what we're going through today is, in terms of objectives, we're going to distinguish between materials that react readily and those that do not, and demonstrate an understanding of the origins of the periodic table and relate patterns in the physical and chemical properties of elements to their position in the periodic table, focusing on the first 18 elements. Heavy stuff. Anyways, you'll see as we go through. So first of all, and I'm going to be kind of moving this around a little bit in order to make this work. Maybe actually I'm better off over here. Am I? Yeah, maybe. Okay. So we're going to talk first of all about metals, nonmetals, and metalloids and where they're located on the periodic table. So periodic table has this staircase line, and I'm going to show it to you on the next slide here, and then we'll go back. This staircase line that actually goes all the way kind of like this, and I'll show you with the pen mode here. So we're looking at this staircase line. Could have used a different color for this, but oh well, we got purple. That goes across here, and this actually separates our metals on the left from our nonmetals on the right. Now, we're going to talk about the properties of metals and nonmetals, but this distinction between knowing that to the left of the line you have metals and to the right of the line you have nonmetals is incredibly important going forward, especially as we start talking about different kinds of compounds. Now, let's say you forget. You just kind of like think, oh, I don't know which one it is. Is it left or right that's metals or nonmetals? Just take a look at some of the elements and it will tell you. So, for example, iron, you know iron is a metal, right? So then you figure out, hey, it's on the left. Now, straddling the staircase line, so boron, silicon, germanium, arsenic, etc., these are actually the metalloids, okay, on either side of this staircase line. The metalloids have properties of both metals and nonmetals. It's a hybrid between the two. We'll talk about those properties in just a bit, but while we're on the screen, I thought I'd point that out. You'll notice I did not circle aluminum because it does not actually count as a metalloid. It is strictly a metal. And you probably know that from learning already about aluminum a little bit. I got to move this up. Sorry. Okay, let's move back now and take a look at this. So again, staircase line separates the metals on the left and nonmetals on the right. Metalloids border the staircase line and have materials of, or properties, sorry, of metals and nonmetals. So we already do that. You've seen it. Again, staircase line is actually seen on your periodic table as this bolded line going across. And it's called a staircase line because it looks like a staircase, if that wasn't horribly obvious. By the way, this periodic table is the one that you would end up getting in Science 10. So I thought right away we'd kind of get you some exposure to the one that you will be seeing in the future. Okay, so metals versus nonmetals, what kind of properties do they have? So if you were to observe them, look at their empirical properties, what would you see? So for metals, they conduct heat and electricity quite well, right? So you think about, for example, a metal frying pan, and it conducts heat. Wires conduct electricity that have metal on the inside. Well, nonmetals, the opposite is true. They do not conduct heat and electricity very effectively. Okay, they're poor conductors of heat and electricity. Metals are normally shiny. Again, when you polish them up, you can actually see that. Well, nonmetals are typically dull in appearance. Now, I should mention for all of this, there's always going to be weird exceptions, but these are generally the properties that we would see. For metals, they are typically a solid with the exception of mercury, which is, of course, a liquid. And then for nonmetals, they're gases or solids, except for bromine, which is a liquid as well. So we have all three states possible for nonmetals, and many of them are actually gases. For metals, they are malleable and ductile. So what that means is I can actually take them and bend them and they don't break. Well, if I take a look at a nonmetal and I try to actually bend a nonmetal, it would break. It's brittle instead. So those properties, incredibly important to actually know. Typically, we would end up doing kind of a lab where you could see the properties of metals versus nonmetals. We don't have that chance here. I don't have samples to show you, but just make sure that you understand these properties. Okay, so moving forward. On the periodic table, there are also groups and families that have similar properties and react in similar ways. If you watch that periodic table crash course video, you'll actually see that this was the foundation for building the periodic table of putting elements with similar properties in the same group. As you will learn later on when we talk about Bohr diagrams, there was a reason for this. Okay, when we actually take a look at things that are in the same group, they have the same number of what's called valence electrons. So it has to do with their electron structure and where the electrons are in the atom. We'll get into that again in a different lesson. Okay, so these vertical columns um, are essentially the groups, and they are labeled 1 to 18. And then we also have the rows, which don't think about rows in a classroom, but instead rows are horizontal. So let's kind of get our pen out here. When I talk about vertical columns, vertical is my up and down, yes. And then when I talk about rows and periods, that's my side to side. So you will see this when we take a look at the periodic table on the next slide. Okay, so moving forward here. Here is my periodic table. On the top, you can actually see my groups, right? So I've got my groups or my families going 1, 2, 3, 4, 5, etc. So for example, this right here is group 1, right? All of these elements are in group 1. Over here, I have group 17, which is called the halogens. We'll talk about those in a minute. So those are my groups going from 1 to 18 across. And I have my periods, which are the rows, right? Starting at number 1, number 2, number 3. As I go across the row, elements get heavier and heavier going from left to right. And then you can tell that they're in order going from like atomic number. So 11, 12, 13, 14, 15, 16. And again, the atomic number is how many protons we have within the atom. If you haven't learned about that already, you're going to learn about that again as we talk about the atom and Bohr diagrams. So essentially, again, our families, our groups, right, are the top, and those are our vertical columns. And then we have the horizontal rows, which are our periods. Elements that are in the same group, the same family, have similar properties. Okay, just like when you look at your family probably has similar properties, right? You maybe have similarities. So that's why we call it the same family or group, is because the properties, again, are very similar or the same. All right, let's move on to the next slide. So we're going to talk about some specific groups. Alkali metals are group 1. They are incredibly reactive and they react very well with water. If you want to have some fun, take a look at some YouTube videos seeing the reaction of alkali metals. This one is great. Alkali metals and water, accurate, just kind of playing this. And I know I don't have the system audio set up, so you can't hear this, but you can see some really good reactions and there's fire and everything. It's fantastic. Okay, so you can check out that video. But alkali metals, very reactive. They are the most reactive metals, and these are in group 1. The alkali metals do not include hydrogen. So if I take a look back at this periodic table, okay, my alkali metals are the metals in group 1, okay, which are right here. But hydrogen, I should have mentioned this earlier, it's on the wrong side of the staircase line. It's actually a non-metal. This is the only non-metal on the left-hand side, okay, but it is here because it has 1 valence electron. You'll learn about that later, which is why it's in group 1. So alkali metals, okay, are right here, but it does not include hydrogen on the top. That is instead a non-metal. Okay, so continuing on, got to erase that. Yep. Group 1, again, it's called the alkali metals, excluding hydrogen. They are the most reactive metals. And it actually gets more reactive as we go down the group. Okay, so when I take a look at lithium, it's less reactive than sodium. And you're going to actually see this again in that video. So francium would be by far the most reactive, but it is incredibly rare. So it's hard to get access to any francium. And I think in a video I heard that there was like very, very little naturally occurring on Earth, like a gram or something in total. I don't know. All right, alkaline earth metals is group 2. These are still very reactive metals, but they're not as reactive as alkali metals. So group 2, that is all of this group right here, okay, are the alkaline earth metals. So again, reactivity goes up or increases as I go down the group. So radium is the most reactive of the alkaline earth metals. And they're called this, the alkali metals and alkaline earth metals, because they actually form a basic solution when they mix with water. So when we talk about like alkaline, that means that it has a base, which means a pH above 7, opposite of an acid, right? So essentially when I have a earth metal, alkaline earth metal dissolved in water, it makes this base type of solution, which is some extra information for you. Halogens are group 17. So this is the second last group when I go back to my periodic table. These are the most reactive non-metals, incredibly reactive. Now, unlike the alkaline earth metals, reactivity goes up as I go up the group. So if I take a look again at my periodic table, this is the most reactive halogen, fluorine right here. While when I go down, chlorine, bromine, iodine, those are actually less reactive. Okay, so this is the most reactive right here. So this is the most reactive nonmetals. If you want to actually see some videos again of reactions, you can watch, reactivity of the halogens or something on YouTube. See a few videos. Pretty interesting. Fluorine's crazy. I'll just say it right now. Fluorine's crazy. It's incredibly reactive. And this is actually why we use these halogens, is because of its reactivity. So it essentially is poisonous because it is so reactive. So you know about chlorine in pools and that it kills germs and bacteria and everything else because of its reactive nature. So reactive, poisonous properties that are often used for cleaning and other purposes. Finally, we have the last group you need to know about by name, the noble gases, which is group 18. These are actually known for their unreactive nature, the fact that they don't react. They are completely chemically inert. So if I take a look at group 18, which is the last group right here, okay, these don't react. They just won't. They won't react with anything unless it's the most extreme of conditions. So that gives us our 4 groups you need to know. Group 1, alkali metals, which excludes hydrogen. Group 2, alkaline earth metals. Okay, and then I have my group 17, the halogens, and group 18, the noble gases. And again, noble gases are known for their unreactive nature. They're incredibly stable. And you've probably seen like neon lights, right? And that's a use of the noble gases. The reason why they are completely unreactive is because they have a full valence orbital at the top, and you'll learn about that again in Bohr diagrams. So when I draw out the electrons for the noble gases, they have a full outer ring of 8 electrons, or for helium, 2 electrons, which means that they are not reactive as a result. And again, you will see that as we get into Bohr diagrams in the future. Okay, when we take a look at elements on the periodic table, each element has a unique symbol that is used throughout the world that actually represents that element. So for example, nitrogen is N. And if we take a look at the different symbols, you actually will see that each one has an uppercase letter, and then optionally, it may have a lowercase letter as well. So oxygen is O, silicon is Si, okay, lead is Pb. So if I take a look again at my periodic table, backing up here, and I know a lot of slide switching around, you can see that these are the element symbols, right? So I have, for example, K is potassium. I know that's weird, doesn't match up. Mg is magnesium. Mn is manganese. So I have all these different elements that, again, has one capital letter for the symbol, and then some have a lowercase letter as well. When we get into the synthetic elements, like down here, sometimes we even have 2 lowercase letters involved. Okay, so these are some examples. You can take a look at a periodic table to actually see all of those, get familiar with it. If I were to actually take a look at how many elements are present in H2SO4, all I need to do is actually just count how many capital letters do I have, right? Because each capital letter for a symbol means I have another element. So here I would have 1, 2, and 3. I have hydrogen, sulfur, and oxygen. And all together, this makes sulfuric acid, an incredibly strong acid. So this would have 3 elements because, again, it has 3 capital letters. Here's another one. What elements would you find in CaCO3? Well, I have 1, 2, 3 capital letters, so I have 3 different elements, and they would be calcium, because calcium is Ca. Maybe I should use the pen here to kind of point this out. Calcium is Ca, right? I've got carbon, which is the C, and then finally I have oxygen. Okay, now this lower kind of smaller number here, the subscript, that's actually telling how many atoms I have of that element within the compound. We're going to deal with that later on when we actually get to formulas. So right now we're not concerned about that. We're just instead concerned about the fact that we have 3 different elements within this compound. Okay, and let's erase this slide and move on. All right, that's actually it. So that is your periodic table. What I hope you got out of this is number one, where the metals are on the left of the staircase versus the nonmetals on the right. The metalloids are straddling that line. Important to know properties of metals versus nonmetals. So review those. Things like metals are conductive, right? Well, nonmetals are not. Metals are shiny. Nonmetals are dull. Metals are malleable. Nonmetals are brittle. So know those facts. Know your facts of metals versus nonmetals, and then know that metalloids have a mix of both properties, which makes them incredibly useful, like silicon being in transistors, right? It's because it actually conducts just a little bit. Because it is a metalloid, it's not fully conductive like a metal, and it's not completely unconductive like a non-metal. It's somewhere in the middle. Okay, so know those properties between metals and nonmetals. You need to know what the groups are and the periods. That groups are similar properties, right? Which is why we also call them families. And it's the vertical columns on the table, while periods are our horizontal rows. When I take a look at groups that have similar chemical properties, I have 4 groups you need to know by name. Group 1, alkali metals. Group 2, alkaline earth metals. Group 17, halogens. And group 18, the noble gases. And be familiar with the properties of all of those groups that you should know by name. All right, that's it. Have a good rest of your day, grade 9.